Solve 2 cosine squared x plus 3 sine x equals 3 for x on the interval 0 is less than or equal to x is less than 2 pi. I start out here by writing the Pythagorean identity, which is sine squared x plus cosine squared x is equal to 1. The reason I'm writing that identity is I've got cosine and sine mixed together here. And if I can somehow use this identity to get this all in terms of cosine or all in terms of sine, that would make this a little bit easier to solve. So what I'm going to do is I'm going to take this Pythagorean identity and I'm going to try to write it in terms of cosine squared x. The way I do that is I subtract sine squared x from both sides of the equation. When I subtract sine squared x from the left-hand side of the equation, I get cosine squared x. When I subtract sine squared x from the right-hand side of the equation, I get 1 minus sine squared x. So now that I have cosine squared x written in this fashion, I can replace that in this equation right here. So starting with our original equation, which is 2 times the cosine squared x plus 3 times the sine of x is equal to 3. I will replace cosine squared x with this quantity right here. So I now have 2 times 1 minus the sine squared of x plus 3 times the sine of x is equal to 3. I will distribute this 2 and wind up with 2 minus 2 sine squared x plus 3 times the sine of x is equal to 3. Next thing I'm going to do is I am going to subtract 3 from both sides of this equation, and that will give me a 0 on the right-hand side. So when you subtract 3 from the left-hand side, you get negative 1 minus 2 sine squared x plus 3 sine x is equal to 0. Now, it may not look like it, but this turns out to be a quadratic formula, and it is a quadratic equation. It is a quadratic equation in sine of x. So I'm going to do 2 steps at once here. I'm going to multiply both sides by negative 1, and I'm also going to put these in order. This will be the first term. This is the highest power term. This will be the second term, and then this will be the third term. So when I do that, I wind up with 2 sine squared x minus 3 sine of x plus 1 is equal to 0. Now at this point, I have a quadratic, and hopefully that quadratic can be factored. If it can be factored, then what we'll have is we'll have 2 separate equations to solve. First factor we'll put over here, and that is 2 times the sine of x. And over here, we'll just have the sine of x. Now, if this is a little bit difficult to think about, it's perfectly fine to temporarily replace sine of x by y, and then you have 2y squared minus 3y plus 1 equals 0, and that'll look a little more familiar. But you can still factor it in this form right here. We have a constant term of 1, so we are going to put a 1 here and a 1 here, and because this middle sign is a negative, I'm going to go ahead and put minus 1 in both positions. Now, the next step is to go ahead and to make sure you did that factoring right, you would do FOIL to make sure that these 2 multiplied give you this term, and they do. Then outside, you would do this times that is minus 2 sine of x, and this is minus 1 sine of x. That gives you minus 3 sine of x. And finally, negative 1 times negative 1 gives you 1. So this is factored properly. We have one thing multiplied by another thing is equal to 0, and that is to say that 2 times the sine of x minus 1 is equal to 0, or the sine of x minus 1 is equal to 0. So now we have two different equations to solve, and let's start with the first one. The way you solve this equation is, first of all, you add 1 to both sides of the equation. When you add 1 to the left-hand side of the equation, you get 2 times the sine of x. When you add 1 to the right-hand side of the equation, you get 1. The next step is to divide both sides of this equation by 2, and when you divide the left-hand side by 2, you get sine of x is equal to 1/2. Now, where is the sine of x equal to 1/2 on 0 is less than x is less than 2 pi? Well, sine of x is the second component, and the sine of x is equal to 1/2 right here at 30 degrees. And also, the sine of x is, the second component is 1/2 over here as well. So if we were to label those, and we'll do these in maybe radians, the first angle is pi over 6. That satisfies that equation. The second angle is x equals 5 pi over 6. So there's two positions, this point right here and this point right here, where the sine of x is equal to 1/2. Now we can go back and work on this side of things. The way you solve this equation is you add 1 to both sides. And now we have the sine of x when you add 1 to the left-hand side, and we have 1 on the right-hand side. Well, where is the sine of x, which is the second component on the winding function? Where is that equal to 1? The sine starts out at 0 here. It is only 1 at this point, right up there. So that point right there corresponds to the angle x is equal to pi over 2. So the answer to the question, when is this equation satisfied for x values between 0 and 2 pi? It's satisfied at 3 different x values, and those x values are here, here, and here. In this case, they are all written as radians. If you would like to write them in degrees, you can also do this. This x is 30 degrees. This x is 150 degrees. And finally, the last x is 90 degrees.